The American Geophysical Union is committed to advancing Earth and space sciences, with 2023 being declared the year of open science. This year's annual meeting is taking that concept even further.
Welcome to AGU 23.
This is AGU TV.
Today we are focusing on
wide open
innovation.
Welcome to San Francisco and to AGU 23. I'm Laura Krantz, your host of AGU TV. As we welcome more than 25,000 attendees from 100 different countries, we are celebrating the year of open science. And specifically today, innovation.
Straight ahead, we'll discuss scientific data visualization in virtual reality.
From an unexpected career in firefighting, I became a scholar on fire and began writing books on fire and humanity. And I'll discuss why fire on Earth looks the way it does.
We'll deep dive into the important industry trend of conversational AI. Hi, Laura.
As President-elect of AGU, I'm going to take you through my priorities for the upcoming year.
Hey, nice to see you again.
Yes, pleasure.
You can find the latest AGU TV episode on the TVs placed throughout the convention center, on the in-house channels at several of our partner hotels, on the homepage of the AGU website, and on our YouTube channel and on X, formerly known as Twitter. We're kicking off this second day with AGU's President-elect Brandon Jones. He's recognized for advancing undergraduate and graduate education programs in the geosciences, and he's been a champion for diversity and equity in all science. Given his background and his leadership role with AGU, we thought that Brandon would be the ideal person to talk to about this year's theme, Wide Open Science. Thank you so much for joining us today and taking the time to come speak with us. So let's say you're in the elevator and you've just got a few minutes to explain AGU and its theme. How would you explain this year's theme of wide open science to someone?
Yeah, sure. So for me, wide open science means accessibility. It means what we're doing at AGU is creating a connective kind of framework for people to receive the science that we support our members in doing, but also opening up opportunities for more collaboration, which is going to make the science better overall. So that theme really resonates with our strategic plan and all that we're trying to do as an organization in the research enterprise.
As part of this, there's a real push for innovation, which happens to be today's theme for AGU. Tell us about some of the innovations that you're excited about and things that you see coming down the pipe that seem really, exciting to you.
Sure. So one that's coming to mind is in our publications realm, and that's a new journal on AI and machine learning. I think it just opened up earlier this month, and we already have some submissions coming in. So we're really excited about that since AI as an innovative tool is taking over the world, right?
Yeah.
And so how are scientists going to use this? How will it be integrated in learning and education for early career undergraduates, graduates that are coming into the Earth system sciences? And so to have a journal, an innovative journal that's dedicated to that particular tool and science and discipline, I think is awesome for AGU.
Yeah. And, especially at a time when there feels like there's a lot of tension in the world and a lot of divisiveness, like how do you see these kinds of innovations and collaborations making the world a better place, bringing people together?
So wide open science connected to the innovation is also about the people. Research, science doesn't conduct itself. It's a social enterprise. And so if the people don't have access to what they need, the data or the information or the avenues to partnership and collaboration, then our science, not that it won't advance, but it can become kind of stymied. So in that innovative spirit, we're offering something that allows for people to come into, let's say, like a maker space, which is here at the meeting, to really collaborate and start moving things forward with scale and speed.
So big gatherings like AGU 23 really do foster innovation and bring people together and get new ideas flowing. Can you think of examples from previous AGU meetings that sort of shine a light on this?
Sure. So AGU supports all kinds of meetings throughout the year. So of course the annual meeting is the big one, but we support Chapman conferences, and we partner with other organizations at AGU headquarters to host their conferences. So I'm thinking of one in particular. In 2022, AGU partnered with some other entities to host the Justice in Geoscience Conference. And that conference brought in all kinds of experts from around the world, really. And it was led by some of our early career members. And the way that conference was structured, the format of it was so different. There was science content, but there was a focus on self-care. There was a focus on professional development. There was a focus on building, as I mentioned, that network for the discovery science to meet solutions that are needed in communities that have been, say, disproportionately impacted by climate change and things of that nature. So there was intention, and it was a different kind of conference. It was innovative.
Yeah. That sounds amazing. And you said that it was sort of the next generation of scientists that are leading this. You've had a lot of experience in education. How do you see innovation helping the next generation of scientists, and sort of what the next generation of scientists already knows helping innovate AGU as it is?
Sure. So I see it as an opportunity for the generations across the research enterprise to come together, listen, learn, innovate from each other. And connected to that, which I think is really important, is that the early career Earth and space scientists seem to be approaching science from that solution space. So yes, there's discovery, yes, there's curiosity, which may bring people in and draw people in because there are questions. But the early career scientists want to take whatever the data is or the products from the science and bring it to the communities to address whatever issues those communities are facing. And so it's more about the applied nature of science than maybe just the traditional. But they're both needed, they're both valuable. And as science is a social enterprise, how we balance that and how the generations can interplay between one another to make that happen, I think is where AGU can offer that space and place.
Nice. So science, not necessarily just for science's sake, but how do we make science make the world a better place?
Exactly.
Okay. So is there any one thing that AGU is doing that you're particularly excited about looking ahead into the future?
Yeah, I will say that we are making inroads into implementing our strategic plan. So the strategic plan came about in 2020. Of course, the world was on pause there for a couple of years, but AGU was not. And even though we may not have been meeting in person, such, we were still behind the scenes making sure that we had our programs and initiatives and our volunteer leaders and the work that they're doing, everything aligning with that strategic plan. So I'm looking forward in 2024 to actually having a stronger implementation focus on how we can connect everything AGU is doing and supporting to that strategic plan.
Brandon Jones, thanks so much for your time. I hope it's a great conference.
Thank you.
Turning now to those organizations and institutions setting the standard in innovation. CUTE, NASA's first CubeSat to study planets outside our solar system, is providing exceptional data about hot Jupiters. Let's take a closer look at these planets outside our solar system that are so close to their stars that they lose their atmospheres.
The mission of the Laboratory for Atmospheric and Space Physics began as studying from space the Earth's atmosphere, near-Earth space, and the sun. Over time, our mission has evolved to be studying the planets in our solar system.
CUTE is the Colorado Ultraviolet Transit Experiment. It's also actually small and cute, and it really had two purposes. One, to see if we could actually use a small spacecraft to do really fundamental science. And then a second, we wanted to understand more about the atmospheres of these hot Jupiters.
It took time for us to actually wait for CUTE to observe over those several hours of time and then get the data down and then process it and then try to look for the signal there. But once we saw the signal, it was like, a sigh of relief. It was, oh, thank goodness it's working. It was, my gosh, finally, we have data that nobody else has seen before.
Our hands-on training is among the most powerful and maybe in some ways the most unique aspect of education here at the university.
Stephen Pine is a fire historian and an emeritus professor at Arizona State University. He's authored over 30 books, many of them about the relationship between humans and fire. Because climate change is marked by bigger, hotter, and more frequent fires, humanity will have to adopt new strategies to deal with them. And to discuss this, we're joined now by Stephen. Stephen Pine, thanks so much for coming in to talk to us today. We know you're going to be getting into this in your plenary, but can you talk a little bit about this relationship that humans have with fire and some of the key points and how it's evolved?
Wow, humans and fire is a great story. It's a great story for humanity, but it's also a great story for the planet. You know, we got big heads and small guts because we learned to cook food. And then we went to the top of the food chain because we learned to cook landscapes. And now we've become a geologic force because we've begun to cook the planet.
So you've been studying this for 30 years, 40 years, 50 years?
Yeah.
I mean,
60 years.
You've had a lot of experience like learning about this. Is there anything you see going forward that we need to do to address this challenge?
Well, I think that the fire community likes to deal in triangles, fire triangles. So here's my triangle for dealing with what I think of as our coming fire age, or maturing fire age. We've got a problem, we've got too much bad fire, and we've got too little good fire, and we've got way too much combustion. Bad fire, fires that destroy communities, kill people, trash important ecological services. We've got to attend to those, and we can fix that. Getting good fire back in, that's going to be trickier. It's easier to take fire out than to put it back in because conditions change. But we've got to do that. It's going to happen, whether we do it or it happens by accident or nature. And getting control of our binge burning of fossil fuels has got to be a part of that. Otherwise, we'll simply override all the mitigation measures. Ultimately, we'll override all the mitigation measures that we put into place for fire. And at that point, we have created a runaway fire age.
Dealing with this seems like a moment for everyone to be sort of sharing information and sharing practices and looking back in textbooks or books from like 1,000 years ago. How are they dealing with fire in the same way that they're looking for antibacterial stuff from 1,000 years ago? Like, this seems a moment to be sharing information and be very open with the science.
Well, yeah, fire integrates its surroundings, and we don't have a fire science that can do the same. I mean, the line I like to use is that all the other ancient elements, earth, air, and water, have disciplines devoted to them, whole academic departments. The only fire department on a campus is the one that sends emergency vehicles when an alarm sounds. Fire disappeared as a landscape fire. Instead, we created combustion. And to do things with combustion, that is not solving most of the problems we have now.
So where do we go from here? How do we balance the needs of, communities and humanity versus the sort of needs of ecosystems and the need for there to be fire in these landscapes?
Well, I think we need to do everything all at the same time. I mean, we need to prioritize. Clearly, we've got to protect our communities, our municipal watersheds, and the rest. But that's a targeted project, and we can fix most of that. It's ridiculous that power lines are starting fires, for example, around communities. Getting the landscape in better shape, it's going to need some creative thinking about how to reintroduce fire. We've got to be much more varied and pluralistic in our thinking. Getting control of climate change, I mean, we've been trying, but we've got to do a lot better.
Yeah. Stephen Pine, thanks so much for taking the time to speak with us today.
My pleasure, thank you.
Satellites, remote sensors, on-the-ground observations, there are lots of ways to monitor the Earth. But to get really refined and detailed information, scientists need to have equipment in place that can monitor the environment for long periods of time without running out of power. Kirk Martinez is a professor of electronics and computer science at the University of Southampton. He has over 20 years of research experience with environmental sensor networks, and he joins us now to talk about some new innovations in the field. Kirk Martinez, welcome to AGU TV.
Glad to be here.
Tell us a little bit about how Earth sensing systems have changed.
Over time, it's been possible due to the miniaturization of electronics for people to have sensing systems which are much smaller and lighter and can communicate so much more easily than before. So it's giving people the capability to go to more remote places with more equipment, take more readings from newer places.
Yeah, and tell me a little bit about why this was important. Like, what obstacles were scientists running into?
So one of the classic obstacles was having to carry some equipment for many kilometers, place it and set it up, and then leave it there for a year, or visit it a few times to get the data. So you never really knew if it was working, and you could come back and discover it was really just dead for 6 months. So with the newer systems, you can get the data every day. So not only do you get the excitement of getting your data frequently, but you know if the system needs some extra work to get it back to fixed.
Tell me a little bit about the systems that you have created in terms of, like, you know, how are they extending battery power, or how are you making sure that they don't run into the same pitfalls that some of these other systems were?
Yeah, so over the years we've developed systems which use much, much less power, so they can have a very small battery, be lighter, have a small solar panel, and carry on doing the measurements on their own, and also be slightly sensitive to things. So when they run out of power, they might take fewer measurements or communicate less, and so on. So it really gives people the ability to know the thing will work without having to carry lots and lots of batteries or have huge systems to generate power.
Yeah, and I would imagine that this is great information to be sharing openly at a place like AGU with all these scientists here, all of them needing to take measurements. And
yes, and much like people use computing for all their science, a lot of people use sensors and instrumentation, and all of those things need power, and a lot of them need networking so that you get your data back. So it's a common problem with common solutions, which is great.
And you work with glaciologists, but I would imagine that this will work. These technologies will be valuable to scientists across the board.
Yes, that's right. So although we're basically putting something a bit like an animal tracker, but on a glacier so we can see its movement precisely. These technologies allow people to take measurements for forestry type things, volcanoes where it's very dangerous to go near it, places where you would need some kind of special equipment to do your measurements in many places and get the data back live.
Do you see anything coming in the next 5 to 10 years that has you pretty excited about where you can go next with this?
There are some very interesting communication technologies that are emerging, for example, nanosatellites, which allow people to send data from anywhere on the planet with a reasonable cost, but also being able to leave the sensor to make its own decisions and do some machine learning type approaches, which sounds strange, but for example, if you're capturing a lot of video, you don't really necessarily want to send it all home. You just want it to find the interesting parts for you, and that kind of thing is now possible on a tiny, tiny chip.
Great. Kirk Martinez, thank you so much for joining us today.
It's a pleasure.
Now it's time to hear from you. We took to the convention floor to hear straight from attendees about how you are being innovative. Take a listen.
I think the innovations that excite me the most are like integrating AI and computer science into data analysis. Because by utilizing these like new technologies, we'll be able to advance our fields in a period of like 10 years in what would have before taken like 50 or maybe 100.
I do a lot of work with urban climate, and I'm very interested in both physical representations of urbanization in global models, as well as a lot more data-driven estimates, such as from machine learning.
I'm more interested in how like humans are dealing with wildfire and what we can do to bring a solution around wildfire management issues.
Since I work with climate variability and change, I'm excited to see about the new products of radar, satellites, and how can we apply those products to study more and research more about extreme events in the future, like droughts, precipitation, and tropical cyclones as well.
Science is open when science is collaborative and interdisciplinary. scientist community. It brings people together and it can be one of the most beneficial and helpful resources for like anyone.
Science is important because it's all around us. We breathe science, we need to make it open, we need to make it available for everybody to study science.
Anybody and everybody has access and they can figure it out themselves. It's logical. That's like, the coolest part about science.
Trying to do some sort of work which could be helpful for humanity and to create a better world for the upcoming ones and to let them know about the things that's happening around. This is really cool.
Can artificial intelligence and virtual reality help scientists and the rest of us better understand climate change? For Shayna Solis, the answer is yes. And these innovative technologies can also help make science more equitable and inclusive. Shayna is the co-founder and CEO of Navka, and she joins us now to talk about her work. Shayna, welcome to AGU TV.
Hi, Laura. Nice to meet you.
Tell us about Navka and what the kinds of work that you're doing and how this company came to be.
Thanks. So we're a technology company. We're located just outside of Washington, D.C., and we really look at technology tools for science, and that is cloud computing, it's high-performance computing in the cloud, it's game engine technology for immersive data visualization, and it's also artificial intelligence.
And game engine technology, how does this work? What exactly is that?
A lot of people think of it as virtual reality or augmented reality. The game engine is the underlying software that really powers video games. So when you think about all of those games or a virtual world, we really were interested in using that same technology, but for scientific and geospatial data visualization as a really different approach to visualization, being able to create a virtual world that's entirely data-driven and then be able to explore it.
Sounds very futuristic, as does AI and VR and all of these other things. What got you excited about these? Like, why did you want to get involved in these particular fields?
I've always been very interested in that intersection of creativity, art, technology, science, and having a company is really the way to do that because nobody's telling you no, the sky's the limit, so we have sort of unlimited possibilities in terms of taking emerging technologies, experimenting with them, and then seeing if it's something that we can implement.
And can you talk a little bit about how these innovations are helping scientists?
Absolutely. So we do a lot of work with NASA and with some of the other federal scientific agencies here in the United States. And that could be working alongside their high-performance computing teams, working alongside scientists to really help them to leverage cloud technology. A lot of this is being really used to push the envelope for open science and building platforms that allow people from all over the world to be able to access not just NASA data, but also compute resources in the cloud. That's one example. Also, of course, these innovative technologies with the game engines and with artificial intelligence are really changing the way that we can communicate about science. We can translate information into visual frameworks and also into conversational language that can help people understand this complex information.
And you're doing something with fire, if I am correct, in looking at the schedule. You're presenting later this week on how this information or how these technologies can be used to think about fire and the challenge that it poses with climate change.
Yeah, so one of my hats, multiple hats that I wear is the principal investigator for a wildfire grant project. This is through NASA's Applied Sciences program. And we've been really looking at the game engine technology as a way to create an interactive framework. So bringing in lots of different types of data sets. We did a case study on the Hermit's Peak fire that occurred in New Mexico in 2022. So I'll be presenting this on Friday in an e-lightning session in the afternoon. So don't go home, stay. And we'll be showing that. And also we've brought in the conversational AI piece with our own tool that we built called Voice Atlas. And it actually answers contextual questions about the visualization that you're looking at. So I'm super excited about it as sort of the next generation of how we can use these visualizations in an interactive way.
Yeah. You have also talked about how these technologies can be useful for making science more inclusive and diverse and equitable. Can you talk a little bit more about that?
Yeah, so in a visualization platform like the one that we're developing, you can imagine you have stakeholders from lots of different backgrounds. They don't necessarily have to have a scientific or research background to be able to understand visually what's happening. Also people from the private sector, from utilities, from state and local government and other decision-making bodies. It gives a common ground place where people can look at this. And then the conversational AI piece, I think, is really important as well, because it really can make information more accessible. If you don't know what you're looking for in a data repository, if you don't know the right metadata tag, for example, the information might be there, but you couldn't find it. So the conversational AI piece can really help bridge that gap and make the information more accessible and more discoverable, which hits squarely on some of the open science goals that a lot of groups have.
Yeah, and looking ahead into the future, even more in the future than this already feels, are there any technologies or innovations that you're anticipating?
Everybody's talking about AI, so I think artificial intelligence definitely is going to be the big one, whether that's a general artificial intelligence that's baked into a lot of our devices that we interact with. But I'm optimistic also that there's real possibility for it to help humans to overcome some of the challenges that we're facing, whether that's discovering cures for diseases or additional solutions to address climate change, that hopefully we can use this technology in a positive way to have good outcomes for everybody.
Shana Solis, thank you so much for joining us today.
Thank you. Thank you so much.
CW3E is a leader in atmospheric river research and applications. Through research and operation partnerships, CW3E has integrated science, technology, and improved forecasts into water management operations to build resilience to droughts and floods.
The Center for Western Weather and Water Extremes, which I'll call CW3E, was created to help address challenges with Western water management because we have such big extremes in wet and dry. One of the big challenges for California and the West Coast in managing water is that a ton of it comes in just a few storms each year. Those storms are atmospheric rivers, and they form over the Pacific, and there's usually not as much measurements as we have for storms over the continent. That is the purpose of atmospheric river reconnaissance, is to capture, measure, and feed that into the forecast models to better predict atmospheric river landfall on the West Coast. In coming here 10 years ago from a federal agency and starting a center at a university, one of the goals was to explore how to educate a new generation of young people in the possibilities that science creates to make the world a better place.
Modern technology has made it possible to not only collect a lot more data, but also to see it. To explain how this works, we reached out to Christina Collins, who's a postdoctoral research fellow at the Space Science Institute in Boulder, Colorado. Christina Collins, thank you for joining us today.
Thank you.
So when I think see my data, I'm thinking the matrix, and I'm pretty sure that that is not correct. Can you explain this idea of seeing your data?
Well, there's a lot of different ways to present data in 3D. Often people will take data and they will put it into a 3D format by creating their own application. And some of the things that we'll have at our session on Thursday are in that vein. I'm particularly excited about generating point clouds from just any sort of tabular data and then looking at those point clouds together. So if you have a table with an X column, Y column, Z column, and something that you want to color map, you can turn that into a shape. And then you can put data sets from multiple different instruments into one place and look at them together.
And you can actually walk through your data. I think this is what you'll be talking about at your poster session.
You can, yes. So if you come by, hopefully we'll have some VR headsets available, and people will be able to walk through Antarctica or satellite paths or various representations of different things. And obviously, Earth and space science is a great category of data to look through because everything in it is already spatially associated with something.
Why is virtual reality such a great tool for scientists? Because I usually think of it in terms of gaming, but what are the advantages of using it as a scientist?
Well, there's virtual reality, there's also mixed and augmented reality. And for all of these, I always come back to the 3D aspect. Virtual reality in general, you can create and share experiences with people in a direct and repeatable way. One of the things that I really enjoy is when people put on the Microsoft HoloLens and put an object in the room in mixed reality, and then they'll say some sentence that doesn't make any sense at all. You know, like I put the air traffic control tower in the middle of Liam's head, for instance, is a sentence that I have heard. And everyone in the room is like, well, that does not make any sense to me. And then they try it on and it makes sense to them. So you can express really pretty complicated concepts sort of post-symbolically in that way.
Mm-hmm.
You can create an experience and then you can share that experience exactly as you experienced it. So when it comes to taking that and mapping that back to the concept of looking at quantitative data, we respond well to having data in a three-dimensional space, mapping information onto a territory. And so for a science use case perspective, frontier studies where you're looking at data from multiple instruments, where, for instance, you have satellite measurements and ground-based measurements. These are changing in relative position in terms of time. There's a lot to keep track of. When you express that in VR, the information can just sort of fall out the way that it does when you make a really great graph.
Was there a moment as you were sort of learning to use these kinds of tools that you were just like, oh gosh, I can see how this is going to change my research, or how this is going to change someone I know's research, or, completely revolutionize the field? Was there just this sort of like, moment?
I don't know about completely revolutionize the field, but there have been a lot of moments of real serious satisfaction with it. One thing that I'm working on in my own work right now is a study that involves ground-based data from magnetometers in the Arctic and Antarctic, and then they're looking for ultra-low frequency waves. And then I'm also looking at satellites that are going through the magnetosphere. So when I put this into plots, I can look at a certain set of dimensions at any given time, but when I look at it in VR, I can see where everything is relative to everything else. And I can walk through the satellite paths and observe where they are relative to the satellites on the ground. So it's very satisfying when you're able to create a good representation of your data.
Cool. Christina Collins, thank you so much for joining us today.
Thank you.
In a world of vast landscapes and intricate ecosystems, America View stands at the forefront of Earth observation education. This nationally organized network not only educates, but also communicates vital information from the grassroots level to federal platforms.
American View is a nationally organized, university-based, and state-implemented program that focuses on Earth observation and remote sensing through applied research, education, outreach, workforce development, and technology transfer. We work across 41 different states across the United States, and each one of our states are called state views. And each one of those state views has an opportunity to focus on local issues, address educational needs, and identify different types of opportunities where we can use remote sensing and Earth observation to address local issues and support education.
America View is helping our students understand how they can make a change from the local scale that scales up to the state, that potentially could impact something on a national or even global scale, that making a difference in taking this technology that they've learned, the data that they're using, to be able to affect change, often working in a very local environment, but understanding how they fit in the bigger picture.
Ultimately, America View is creating partnerships and opportunities to empower Earth observation and train the next generation of remote sensing scientists and educators.
You can find the latest AGU TV episode on the TVs placed throughout the convention center, on the in-house channels at several of our partner hotels, on the homepage of the AGU website, and on our YouTube channel and on X, formerly known as Twitter. Join us here tomorrow as we explore the importance of community.